Hello and welcome to this course in IBDP HLSL, and today we are going to talk about SL 5.8, which is approximating areas using the trapezoidal rule. We will discuss the concept behind it and a few problems on it. Okay, so let's talk about the trapezoidal rule first. Basically, if we have to find the area between the curve y equal to fx between the line x equal to a to x equal to b, where b is greater than a, then we divides that area in n trapezoids, and the width of each trapezoid is given by this b minus a over n, where n is the total number of trapezoids we need, b is the upper limit, a is the lower limit in that graph. I'll show you. Consider a function whose graph is given by this. Let's say this is the graph of y equals to f of x. So we need to find the area under this curve from x equals to a is the equation of this line to x equals to b, this line. Okay. Now we have to construct n trapezoids here. So I'll start with drawing a line perpendicular to x-axis from the point lying on the curve by taking this width as this h value, which is b minus a over n. Let's represent it by delta x. Okay, so this is our delta x, which is the width. Now let's join the endpoints here to this, like this. Now we have a trapezoid, as you can see. We know the area of a trapezoid is given by what? Let's call it a1. So in this way I will divide this area into n trapezoids. Okay, and later I will add up all these values to find the value of a final area. Let's consider a1, a2, a3, and so on up to last one is an. Be the n trapezoids. So the final answer will be approximately a1 plus a2 plus a3 plus so on up to an. Area A1. We know the area of a trapezoid is given by, if you have a trapezoid, let's say this line and this line are parallel sides and these are non-parallel sides. So this side length is, let's say, A, this side length is, let's say, B, and the distance between these two parallel sides is D. So the area is given by half times sum of the parallel lines, which are A plus B, times the distance between them, which is D. So in this way I can say this height, let's call it y naught. Okay, which is what? If I try to find the coordinates of this first point, what are that? So here the x value will be a and the y value will be f of a. So I'm calling this as y naught. Similarly, this height is, let's call it y2, y1. This height, let's call this one as y2, and so on y3, and the last one, this height is going to be yn. Okay, so using this we have exactly n trapezoids. So the area of first trapezoid is half times the width, which is either you can say delta x or h. So here h times the sum of two parallel sides, that's y naught plus y1. Similarly, the value of area 2 will be half h as it is. Then we have y1 plus y2. Similarly, for A3, I will have half h times y2 plus y3. So on for an comes out as half h of yn minus 1 plus yn. Correct? Now, if I have to add up all these, a1 plus a2 plus a3, what can I say? It must be equal to half h common, half h, that is common in all those. So take it out common. Now you observe y naught is appearing once if I add up all these, and yn is also appearing once. Other values like y1 is appearing twice. Similarly, y2 is appearing twice, and so on. So I can say I will have y naught plus yn plus twice the mid values. So they are y1 plus y2 plus so on up to yn minus 1. That's it. That's the area using the trapezoidal rule. So it means we can approximate the answer. Basically, we have to draw these trapezoids. So you may get a overestimated or underestimated area, that will depend on the equation of the curve, whether it is overestimated or underestimated. Okay, so that's the final answer for finding the area of y equal to fx from x equals to a to x equals to b using the trapezoidal rule. So all you need is you have to find the width, which is given by b minus a over n. They will give you in the question how many strips you have to take. So n is given to you, a and b will be given to you, and now you have to only find the values of the function at all these points. Okay, so as I said, if this is check whether it is underestimated or overestimated, you need to check the graph for that. Okay, let's consider a problem. It says use the trapezoidal rule with 4 trapezoids. So here this shows that you have to do it for n equals to 4. Approximate the value of the area between the curve. So y is equal to this. You have the equation of the curve as well. So from here, can I say f of x is equal to 2 plus 6 by x from with x-axis from x equals to 1 to x equals to 3, right? So what I have here, I have n value which is 4, a is 1, b which is 3, and also the fx value which is 2 plus 6 over x. So now I need the h value. What is h? Is given by b minus a, which is 3 minus 1 over 4. So that's the value, which is half. Now I have h equals to half. I have to start from 1, x equals to 1, and I have to go till 3 by taking the differences of what? Half. So next value will be 1.5, then 2, then 2.5 and 3, right? So in this way we will end up getting 4 trapezoids. Okay. Now we need the heights as well. So let's create a table, or you can find the values, fx values, by taking x equals to 1, x equal to 1.5, 2, 2.5 using your calculator. Okay. So h value comes out as zero point 0.5. Now let's find the value of y for x equals to 1. That comes out as 8. For y value for the x equals to 1.5 comes out as 6. You just have to substitute that value of x in here to get the value of y. Next, put x equals to 2 here. So you will end up getting 5. Similarly, you can fill this table. Now here I have y values, y0, y1, this is y0, y1, y2, y3 and y4. Okay. Now let's find the area using the trapezoidal rule. So what that says, it says area will be given by half times the width, which is again half, times you have to write the first value and the last value once, means 8 plus 4 plus twice the mid values, which is 6 plus 5 plus 4.4. And you can either use your GDC or you can do it manually. Simplify this and you will get the approximate value of the area under the curve. Okay, that comes out as 10.7. So in this way you can use the trapezoidal rule. One more question. If the table is given to you, right? Equation of the curve is not given. So some values of the function are given in this table. You have to use these values to estimate the value of this integration, means from 5 2 to 5. Okay, from 2 to 5. So your a value is what? 2, b value is 5, and here how many rectangular strips we have? For that we can find the h value, but in the table it is already given to us. If you see h, what is that? The difference between these two, right? And it is always same, so which is zero point 0.5. So here we also have the value of h, which is zero point 0.5. We don't have the value of f of x, right? But values are given already. So we can use the trapezoidal rule and our answer will be half times the h values, which is 0 0.5, times, now write the first value and the last value once, means 1.6 plus 0 0.8 plus, now the twice of mid values, 2.1 plus 2.3 plus 2.2 plus 2.0 plus 1.5. Now you can easily calculate this value and you will end up getting answer. I'm getting 5.47 for this. So that's an approximation to the area under the curve, 5.47 square units. Okay. One more question where the graph is given to us. Okay. So in this diagram of y is equal to x by 2 raised to the power x, you have to use the trapezoidal rule with 5 strips. So you have to construct 5 trapezoids. So n value is what? 5. Starting from what? X equals to 0 to x equals to 2. Okay. So a value is given as 0 here. The value of b is 2 here. Now let's find the h. What should be the step size? So h is equal to b minus a over n, which is coming out as h equals 2 by 5 means 0.4. Okay, so now what can I do? I have the width, right, 0.4, and now I need the value of this uh, function at those points like zero point 0.4. Okay, so take the zero point 0.4, then 0.8, right? In this way we can create construct a table for the values of x and y like this. X will start from 0, okay, and increased by zero point 0.4. So 0 is the first value, then zero point 0.4, then 0.8, 1.2, 1.6, and 2 in this way. So now in this way we are getting 5 strips, right? Now but we also need the values of y corresponding to these values of x. So for that, you can simply use this equation, or you can also use the graph. Okay, that will also give you the same answer. So I will use the GDC. You can enter this value in the spreadsheet and you can get this answer. Okay, so if you want, you can use the spreadsheet also. In the column A, you can write the x values. Okay, 0, 0.4, 0.8, and 1.2, 1.6, and 2. And here for the y values, you can use the formula, which is what? This one. Your x value, you can say a1 divided by 2 raised to the power a1. That will give you 0 here for the first value. Similarly, you can just extend this to get the values of y. Okay, so simply GDC will help you to get these values of y for corresponding values of x. They comes out as 0, 3.0, 0.459, 0.522, 0.528, and 0.5 in this way. Okay. Now, let's find the area. So, area is given by half. Now, the width size, which is 0.4, multiplied by first value, which is 0, plus last value, which is 0.5. Then twice the mid value. So, twice of sum of these values. So you can just enter these values like 0.303 plus 0.459 plus 0.522 plus 0.528. Now simplify it and you will get your answer, or you can say area comes out as 0.8248 using the GDC. Okay, or you can also say is around 0.825 square units. Now if you use your GDC to calculate this integral, like integration from 0 to 2 for this function, which is x by 2 raised to the power x dx, your value comes out as 0.8396, which you can say yes is an this one is an approximate value, right? This is approximate value by using trapezoidal rule, and here this one is the exact value of area under the curve. Okay, but they don't want us to find the exact value. They are saying just use the trapezoidal rule, so you can just leave your answer at this 0.825. That's it. Okay, so now in this session we learned about the trapezoidal rule and how to apply it, right? Estimating the area from the given data or the table was given to us, and also we have seen how to find the area if the graph of the function is given to us. Okay. So that's it for today. I hope you got all these things. Thank you for watching this. See you in the next part. Keep watching, keep learning.